Hey everybody, it's Mr. Mott. What we're going to do is go through how to do objective number 5, and these are the answers. Question 24 says we want to indicate the number of significant figures. So I'll highlight the answers and then the Y for each of these. So for letter A, we got 1, 4, 2, 2. Those are all non-zero numbers, so they are all significant. So there's 4 significant figures there. For B, similar idea. There's 5 significant figures because all of these are non-zero numbers. For letter C, we only pay attention to this first part when we're using scientific notation. And so what we have here is that these some captured zeros, and captured zeros are always significant. So there's 4 significant figures there. The zeros are significant, and of course the 1 and the 4 as non-zero numbers are. For letter D, we're going to only have 1 significant figure. The reason being is that we have these trailing zeros, but there's no decimal anywhere in this number. So trailing zeros do not count without a decimal. All right. Similar idea for letter E. Now that we have the decimal, we have 3 significant figures because now these zeros are significant. All right. For letter F, we're only again paying attention to that first part. There's a decimal in there, so these trailing zeros count. So there are 3 significant figures. G, all non-zero numbers, so we have 6. H, all non-zero numbers, so we have 5. All right. Let's take a look at rounding for question 26. When we round our answers, we want to go to 3 significant figures. This is just an arbitrary value in this particular problem. It's not that we always round to 3 sig figs. This is just how this problem is set up. Start counting at our first non-zero numbers, the 1, the 5, and the 6 are the count. We're going to look next door to see if we should round that first 6 to a 7. I think we should. So 1, 5, 7. And then for all of these other places that we have, we want to add zeros to maintain how big that number is. So we should have 4 zeros then, I believe. 1, 2, 3, 4. All right. So again, we want to maintain how big that number is. We don't want to, if you won the lotto and and this was your prize money, and then they give you $157 because they rounded up. Well, they didn't really round up, did they? They took money away from you. All right. All right, for letter B, 1, 2, 3, and again, we're going to look next door to the 6 to see if we should round up. So I think we should. So 2.77 times 10 to the minus 3. This number is written in scientific notation for some reason. So you don't want to turn it into like a decimal, without scientific notation and go back and forth. Just pay attention to the first part. All right. For our next one, these first 3 digits are going to count because there's a 9 afterwards. The 5 becomes a 6, so 8, 4, 6. And we add a couple zeros in there to maintain how big that number is. For letter D, we start counting at the 1. It's our first non-zero number. Again, we're looking next to the 6 to see if we should round. So this is going to be 0.00117 for our significant figures. We're not going to add any zeros afterwards because there's a decimal here, if I add trailing zeros, they become significant. All right. For letter E, again, we start counting our first non-zero number, and then we're looking next to the 5. Since there's a 9 there, we are going to round up. So 7, 7, 6 for our answer. All right. For 32, here's where we're getting into our rules about addition and subtraction. We're going to focus on decimal places when we're looking at this one here. So you want to have a calculator with you. And I'm going to plug these in. So 212.2 plus 26.7 plus 402.09. And so my raw number from my calculator is 640.99. And we're going to round the appropriate number of significant figures. And the rule is we go by the least number of decimal places. So for our decimal places, we have 1, 1, and then 2. So we're going to round according to our decimal places. So we need to go to 1 decimal place here. And so since this is a 9, we're going to round the first 9 to a 10. So that makes this is a 1 and this is a 0. So our new value is going to be 64. It's really hard to see. 641.0. All right. Now, you weren't asked to then identify how many significant figures in this value. Just round according to the significant figure rule. All right. All right. For our next one, 1.0028 plus 0.221 plus 0.10337. My raw number for my calculator, 1.32717. We're going to go to our smallest number of decimal places. We have 4, 3, and we have 5. So 3 is our smallest value, 1, 2, 3. We're going to look next door to the 7 to see if we should round. So this becomes 1.327, and we're not going to round that 7 up because there's a 1 after it. Our next one, 52.331 plus 26.01 plus, minus 0.9981. And we are going to get 77.3429 as our unrounded raw answer. Our least number of decimal places is 2 from this value. So we're going to go to 2. And we're going to look next door to see if we should round. The 2 does not round the 4 up, so it's just going to be 77.34 for our answer. For our next one, leave these numbers in scientific notation. So 2.01 times 10 times 10 to the second plus 3.041 times 10 to the third. And my calculator actually put this into regular numbers for me, which is kind of weird. 3215. So since we're adding here, this is sort of weird. Since it changed it into without scientific notation, I guess what I would do is I would convert this into scientific notation. So move my decimal over 1, 2, 3 places. So this would be 3.215 times 10 to the 3 since I moved it over 3. And then I'm going to round it according to my rules here. So again, 2 decimal places here, 3 here. So I need to go to 2 decimal places. So this turns into 3.22 times 10 to the third. All right. Looking at 33, now we're multiplying and dividing. So for 33, we're multiply and divide. Do the calculator, do the math there. 4.031 times 0.02806 times 373.1 divided by 0.995. So my calculator is giving me a really big number. I may not write everything out. 124.0356 and keeps going. And we're going to round to the least number of significant figures. So I should have 4 in this first value. Okay. I should have 4 here, 4 here, and this is 3 significant figures. So I'm going to start counting at the 1. The 1, 2, and 4 are going to count. I'm not going to round the 4 up because there's a 0 here. So this turns into just 124 then as your answer. All right. 12.011 divided by 6.022 times 10 to the 23rd. Calculator is giving me like 1.99452 times 10 to the negative 23rd. We're going to round. So I got 5 significant figures here. And I've got 4 here. So I'm going to go to 4. 1, 2, 3, 4. So next to the 4 is a 5. So we should round the 4 to a 5. So this is 1.995 times 10 to the negative 23rd. All right. For letter C, we've got we've got 0.500 times 44.02, and we get 22.01. Three significant figures from this value, 4 from this one. So to go to three significant figures, 22.0 should be our answer. All right. Next one, 0.15 times, divided by 280. So 0.15 divided by 280.62. And I'm getting a 5.3453 times 10 to the minus fourth. And so again, look at our sig figs. I got 2 here and I have 5 here. So we're going to go to 2. So the 5, start counting at the 5, the 3 counts, but we're not going to round the 3 up because there's a 4 next to it. So it's going to turn into 5.3 times 10 to the minus 4. Okay. All right. So when we now look at 34, we have to keep in mind all of these rules and kind of do them separately. So it's a little bit more of a chore. All right. So for 34, we have combined rules. So you notice that in the top part of this one here, we're adding, but then we're dividing. So which rule do we follow? Well, we follow them both just separately. So what we're going to do is we're going to do this math here first, round, and then we'll divide by this value, and then round again to the different significant figure rules. So for the top one, 2.0944 plus 0.0003233 plus 12.22. And my answer is 14.314.7. So if I do like letter A down here, so I'm getting from this top part, I'm getting 14.3147 and a bunch of other stuff. We're going to go according to our least number of decimal places, which is 2 from this value. And so these two are going to count. So this value becomes 14.31, and then we're going to divide it by 7.001. And so 14.31 divided by 7.001, my raw number is 2.04399, and some more. Because we're dividing now, we got to go by our significant figures. So for my sig figs, there are 4 here and there are 4 here. So 1, 2, 3, and 4. Since we have a 9 next door, this becomes 2.044. All right. And that's kind of how you approach these. You have to do them sort of separately if the rules are different. And so that's sort of the theme for these problems. So for letter B, 1.42 times 10 to the second plus 1.021 times 10 to the third. And it's giving me, without scientific notation, it's giving me 1163. Just to keep it in scientific notation so that we can follow our decimal rules, I'll move over 1, 2, 3. So this is 1.163 times 10 to the third. Now we can round it according to our two decimal places. So I'm going to stop at the 6. We're not going to round the 6 up because there's the 3. So I get 1.16 times 10 to the third. And then we're going to divide that by 3.1 times 10 to the minus 1. So 1.16 times 10 to the third divided by 3.1 times 10 to the negative 1. And we could leave this in scientific notation or not. My calculator is giving me 3741.935 and some more. Because we're dividing, we got to go by sig figs. So there's 3 here and 2 here. So for 2 sig figs, this turns into 3700 for your final answer. All right. Letter C, we have this here, but then we have to do our parentheses here first. So we're going to take our 9.762 times 10 to the minus 3, and we're going to divide it by whatever we get over here. So let's do that separately. So we get 1.43 times 10 to the second plus 4.51 times 10 to the first. And so for this value, we're getting 188.1. But we want to turn it into scientific notation, so we'll move it over 1 and 2 places. So 1.881 times 10 to the second, since we moved it over 2 places. And so now, according to our addition rules, we'll go by decimal places, so 2 in each. So this becomes 1.88 times 10 to the second. That's what we're going to put down here. So 1.88 times 10 to the second. So now doing our math, 9.762 times 10 to the minus 3 divided by 1.88 times 10 to the second. And we're getting 5.19255 times 10 to the minus 5th. Since we're dividing, we're going to go by sig figs. So as far as our sig figs, there's 4 here from this first part, 3 here. So 3 sig figs, we're going to count these. We're not going to round the 9 up, so this is going to be 5.19 times 10 to the minus 5th. All right. All right, for letter D, our last one here, we just are squaring this value. And so in essence, what we're doing is we're multiplying this by itself. So we're just going to follow our multiplication rules. So quantity 6.1982 times 10 to the minus 4, and we're going to square that. So the calculator is giving me, for D, it's giving me 3.841768 and a whole bunch more times 10 to the minus 7. What we're going to do then is go by our sig figs, and there's 5 sig figs here. So 1, 2, 3, 4, 5. We're going to round the 7 to an 8 because of the 6 next to it. So 3.8418 times 10 to the minus 7th is going to be our answer. All right. So those are our sig fig rules. Hopefully hearing them out loud cleared up any kind of confusion. Lots more tutorials and practice sheets out there. We'll be using it all year. So thanks for hanging in there with all these sig fig rules, and thanks for watching.